All right, hello, welcome to today's video. Today we are solving equations. What that means is we are looking for the value of x, or this variable, which will solve this equation, which means makes it true, all right? So if this is negative 11, then we want what value of x will make this side of the equation equal to negative 11, all right? So whatever this number is added to 3 will give you negative 11, and that's going to be the case for all of these questions. We've got 50 questions today. The first 25 questions are going to be one-step equations, solving equations, and then the next 25 are going to be a little bit more difficult. They're going to be multi-step equations. So let's take a look at the first question here. We've got x plus 3 equals minus 11. So whenever we're solving an equation, okay, look at the side with your variable. So maybe if you want to, just to help you visualize, you can even like kind of draw a line down your equation here so that you can see there's two distinct sides of your equation. Look at the side that has your variable and see what's going on with it. Right now your x, your variable, is being added to 3, right? It's x plus 3. So we want to isolate x. We want x to be on its own on its side of the equation. So we have to get rid of this negative 3, right? We have to undo the addition. So to undo an addition, we are going to subtract by negative 3 because the opposite of addition is subtraction. Okay, so we're going to do minus 3. But to have, a balanced equation, to maintain this equation, we can't just minus 3 on this side. We also have to subtract 3 on the other side, okay? So that both sides are still equal. Now on this side, on the left side of my equation, this 3 and this minus 3 are going to cancel out. So I'm just going to do that here, okay? So as you can see on the left side of this kind of vertical line, all I'm left with is x. And on the right side of my equation, I have minus 11 minus 3. That's going to be negative 14. Now on to question 2 here. Once again, just to help you visualize, I'm going to draw a little vertical line to separate both sides of my equation, okay? And on the left side, I have my variable and is multiplying to 9, right? Remember, whenever we have no operation written or explicitly written, okay, so we just have a number and a variable, what's going on between them is a multiplication. So my x is being multiplied to this 9, right? And once again, we want to have x on its own on one side of the equation. We want to isolate the x. So what's going on with my variable? Like I said, it's being multiplied to 9. So we have to undo that operation. So the opposite of multiplication is division. So we are actually going to divide by 9. But I can't just divide by 9 on the left side. We have to divide by 9 on the other side as well to maintain balance. Okay, so this 9 and the 9 are going to cancel out because 9 divided by 9 is 1, right? So if I were to write this, it would be like 1 times x. But 1 times x is just x, right? So I could just completely forget about that 1. We're just going to write x on the left side of my equation, right? On the left side of this vertical line here. We're going to put that equal sign right where it was before, right? Or underneath where it was before, I mean. And 81 divided by 9 is 9. And that's your answer for question 2. Now on to question 3 here, okay? So we've got x divided by 50 is equal to minus 7. So once again, I'm just going to draw a little vertical line just to help you guys visualize. Okay, so x is being divided by 50, and that's going to give me negative 7. So I want to find what x is equal to. To do that, I have to get x on its own on one side of my equation. So I have to get rid of that divided by 50. So the opposite operation of division is multiplication. So I'm going to multiply this side by 50, but I can't just multiply one side by 50. I have to multiply both sides by 50 to maintain balance. Now 50 divided by 50, like I said before, anything divided by itself is 1. That's going to cancel out, okay? So on the left side of this line, I have just x that remains. And on the right side, I have negative 7 times 50. That is minus 350, and that's the answer for question 3. Now question 4 here, I have on the left side 8 times x, right? Remember, if there's nothing explicitly written, it's a multiplication. So if 8 times x is equal to 24, So I have to undo this multiplication to find x to be on its own, right? To have x on its own, I mean. So to undo a multiplication, the opposite of multiplication is a division. So I'm going to divide by 8, right? X was being multiplied by 8. I'm going to divide by 8, okay? So whenever you're trying to figure out what it is you're dividing by, always look at what's going on the same side as your variable. I know sometimes people are tempted to divide by 24, okay? That's on the other side of the vertical line, right? Always look at what's going on with your variable itself, all right? It was being multiplied by 8. We're going to use the opposite operation and then with the same number. So instead of timesing by 8, we now have a division by 8, okay? So the 8 and the 8 are going to cancel out, but we also have to divide by 8 on this side here, okay? Don't forget to do that. So on the left side of my vertical line, I just have an x, okay? Slap an equal sign right there, and 24 divided by 8 is 3, and that's your answer for question 4. Now scrolling right on down here, okay, we've got x minus 6 is equal to 14. Let's draw a little line here, okay? We don't have to do the vertical line if you don't want to. I'm just putting it here to help you visualize, all right? So x is subtracting by 6, and that's going to be equal to 14. Now once again, we want x to be on its own on one side of this equation or one side of this line, okay? Right now we've also got this minus 6, right? It's being subtracted. So the opposite of subtraction is addition. So we have to add 6 on this side, plus 6, okay? And we also have to plus 6 on this side, right? And now this negative 6 and the 6, positive 6, I mean, are going to cancel out because minus 6 plus 6 is 0. So on the left side of your line, as you can see, all I'm left with is this x. So I've got x is equal to 14 plus 6, which is 20. All right. Now, on this question here, we've got x plus 20 is equal to 33. So let's draw a little line here, okay? The opposite of plus 20 is minus 20, right? The opposite of plus or add is subtract. So I'm going to subtract 20, and I'm also going to subtract 20 on this side. So these two 20s here, positive and negative 20, are going to cancel out. So on the left side of this line here, I just have x. And on the right side, I have 33 minus 20. That's going to be 13. Now, 6x is equal to minus 18. I'm going to draw a little line here just to separate these two sides of the equation. Okay, so 6x, what's going on here? We've got a number and a variable. I don't have an operation written here. I don't have a plus, minus, divide, multiply. Okay, it's just a 6 and then x. They're kind of glued together. What that means, once again, is they're being multiplied together. So what's the opposite of multiplication? It's division. So I'm going to divide by what was timesing my x, which was a 6. So I'm going to divide by 6, and I'm going to divide by 6 on this side as well. So the 6 and the 6 are going to cancel out. And so on the left side of this line here, I just have x. I'm going to put an equal sign right here. And negative 18 divided by 6 is minus 3. All right. Now, on this question here, we've got x divided by 30 is equal to 13. Okay, so something a lot of students forget is when you have a fraction, that just means a division, okay? A lot of people are tempted to say like this little horizontal line is a subtraction, all right? Just remember, fractions are divisions, all right? So x is being divided by 30. So the opposite of a division is a multiplication. So I have to multiply by 30 on both sides. All right, so 30 divided by 30, right? We've got 30 on top, 30 on the bottom. These are going to cancel out. So that all I'm left with on the left side of my vertical line, or as you know, as it was originally an equation, right, is just the x, which is what we want. We want to isolate that x, right? And on the right side here, we've got 13 times 30, that's going to be 390. All right, now, next question here, we've got 12x is equal to 60. So as always, if you have a number and a variable just glued next to each other, glued to each other, I mean, then we've got a multiplication. So the opposite operation of multiplication is division. So I'm going to divide by 12. And now the 12 and 12 are going to cancel out, okay? And don't forget to divide by 12 on this side as well. So x is equal to 5. All right, and if you want, once again, you can draw that vertical line. I forgot to do that for this question. And for this last question here, we've got x minus 8 is equal to minus 2. The opposite of subtracting by 8, right? We have a minus 8 here is plus 8. And we also have the plus 8 on that side. These two 8s, well, negative and positive, are going to cancel each other out. So that all I'm left with on this side, on the left side, is the x. And here we have an equal sign. And on the right side, we have minus 2 plus 8. That's just going to be a positive 6. Now, on to the next question. So we've got, I don't know why there was a big break there, but okay, x is being divided by 8, and that's going to be equal to minus 15. All right, so let's draw a little line right here. I'm going to stop doing that soon, but just for now, I'm going to keep adding that little line just to help you visualize the two sides of my equation. I've got my left side here. We've got an x. It's being divided by 8, and that's supposed to result in a negative 15. So my variable is x, it's dividing by 8. So the opposite operation of division is multiplication. I'm going to multiply by 8 on this side. I'm also going to multiply by 8 on that side. Okay, so 8 divided by 8 is just going to be 1. So I'm left with 1 times x, right? But I'm not going to write 1 times x. I'm just going to write x because those 8's kind of cancel each other out. That's why I multiplied by 8, right? That's the whole point. So I get x is equal to whatever negative 15 times 8 is, which is negative 120. Okay, and that's the answer to this question. Now onto this question here. Okay, let's just kind of draw a little line again, right? So if we got 10x is equal to 76, so 10x is on my left side here. What's happening between this 10 and this x? Since there's nothing written, it's a multiplication, okay? So 10 times x results in 76. So I want to undo this multiplication by 10 so that I'm just left with x on this side of the equation. Okay, so I'm going to undo a multiplication with a division. The opposite of multiplying by 10 is dividing by 10. That's going to undo that. And I have to divide by 10 on the other side as well. So these two 10s are going to cancel out. On the left side here, as you can see, is just the x, right? So x is equal to 76 divided by 10 is 7.6, and that's the answer to that question. Now on to the next question here. Okay, so we've got x is being divided by negative 6, and that's going to give me negative 41. So let's draw a little line here, all right? So on the left side of my vertical line, I've got the x, I've got division by negative 6. So to undo that negative 6, I'm going to multiply by negative 6, all right? I know a lot of students like to just multiply by 6, all right? No, it's whatever the x was being divided by originally, the whole thing, which is a negative 6. So I'm going to divide by negative 6, okay? Well, yeah, it was being divided by negative 6. I'm going now to multiply, by negative 6, but I have to multiply both sides by negative 6, okay? So remember, a little dot means times, right? And if you want, just to help you visualize, because that might be a little confusing with the dot and the minus, okay? It's times negative 6. So this negative 6 is going to cancel out with that negative 6. On the bottom here, I just have x, right? That's all that's left on the left side, right? It's going to be equal to minus 41 times minus 6. Because these two things have the exact same sign, they're both negative, I'm going to have a positive number at the end, okay? So it's going to be positive 41 times 6 is 246, all right? Now, onto this question here. I've got x is being multiplied by 11, and that's going to be equal to 7, all right? So what's the opposite of multiplication? It is a division. I'm going to divide by 11. I'm going to divide here by 11 as well. So that when these two 11s divide each other and gives you 1, I get 1 times x on the left side of my line, which is just x, which is what I want, right? I want to isolate my variable. And on the right side, I have 7 divided by 11. That's not going to give me a very nice number. I'm going to leave it as a fraction, all right? And that's irreducible as well, so we could just leave it as 7 over 11. Now, over here, we've got x minus 19 is equal to negative 3. So what's happening to my x is being subtracted by 19, right? So x minus 19 is equal to minus 3. I want x to be on its own on the left side of my equation, right? Let's draw a little line here. So the opposite of minus 19 is plus 19, and I have to plus 19 on this side as well. So these two minus 19 and plus 19 are going to cancel out. I'm left with x here, and that's going to be equal to minus 3 plus 19, which is positive 16. Okay, now over here, we've got 5x is equal to minus 30. 5x, remember, a number and a variable means they're being multiplied if nothing is written between them. Okay, so it's being multiplied by 5, right? My x is being multiplied by 5, I mean. So to undo the multiplication, okay, well, the opposite of multiplication is a division. So I'm going to divide by 5. I'm also going to divide by 5 on this side. So the 5 and the 5 go away. All I'm left with then is x, and on the right side I have minus 6. Okay, negative 30 divided by 5. Okay, it's minus 6. I know it's negative because this was a negative, this was a positive. They have opposite signs, right? So that's going to give you negative 6. All right, so x plus 20 is equal to 27, right? So the x is my variable. It's being added to 12. That's going to give me 27. I want x to be on its own on the left side of my equation. So to undo a plus 12, I'm going to minus 12. But I can't just minus 12 on this side. I also have to minus 12 on this side, right? So 12 minus 12 is 0. That's going to go away. All I'm left with on the left side of my equation is x is equal to 27 minus 12 is 15. Over here, x is being divided by 4, which gives you 9. So the opposite of division is multiplication. I'm going to multiply by something. Multiply by what? The 4. And I'm also going to multiply by 4 on this side. So these are going to cancel out. I get x equal to 36. Okay. Now, over here, okay, 7x equals 42. I want to undo this multiplication here, so I'm going to divide by 7, divide by 7. These cancel out. I'm left with x equals 6. Okay. Over here, x minus 5 is equal to 18. I want to get rid of that minus 5. So instead of subtracting, the opposite of subtracting by 5 is adding 5. So I add 5 on both sides. Those cancel out. I'm left with x equals 23. Now, x plus 7 equals 0. So x is being added to 7, right? Remember, x is the variable, it's the letter. So the opposite of plus 7 is minus 7. Minus 7 over here as well. These cancel out. And x is equal to minus 7. Okay? Over here, we've got x is being multiplied by 4. Right? We have 4x, and that can give you 22. So we want to undo this multiplication here, right? Remember, when you have a number and a variable next to each other, they're being multiplied together. So the opposite of multiplication is division. I'm going to divide by 4. I also have to divide by 4 on this side. So the 4 and the 4 go away. On the left side of my equation, I just have x. And on the right side, I'm going to get 5.5. On to the next question then. Here we've got x divided by negative 10 is equal to 4. So I have to undo that division by negative 10. The opposite of division is multiplication. So I'm going to multiply by negative 10. All right, remember, it's not just the 10. It's the whole thing. It's the negative 10. I also have to multiply by negative 10 on that side as well. So these two are going to go away. On the left side of my equation is just the x here, right? So x is equal to 4 times minus 10. It's negative 40, okay? Over here, we've got 3x is equal to minus 9. Remember, if there's nothing written, it's like there's a multiplication. So 3 times x equals minus 9. Undo that multiplication. Divide by 3. Divide by 3. X is equal to minus 3. Okay, I don't know why I wrote that in pink. It is what it is. All right, and we've got one last just like simple single step equation here. So we've got x minus 1 is equal to 6. So the opposite of subtracting by 1 is adding 1. So we're going to add 1 plus 1 and plus 1 over here. These are going to go away. So x is equal to 7. So that's the first 25 questions. Now we are going into multi-step equation territory. So for these questions, it's really important that you undo whatever's happening to your x in reverse order. So what does that mean? I'll explain it to you in a second. For this question, I guess we'll go back to drawing that vertical line just to help you visualize a little bit better, okay? So where's my variable? It's this x right here, right? And remember, because of order of operation or BEDMAS, right? The x is going to multiply to the 3 first, and then whatever that product is, we're going to add it to 5, okay? So the last thing that happened was this addition by 5. So that's the first thing that we are going to undo, all right? Not this division by 3, it's this addition by 5. That's the first thing we have to undo. We're undoing it in reverse BEDMAS order, okay? So remember, this is a multiplication, right? So we're going to undo this plus 5 first. So what's the opposite of plus 5? We've practiced this enough already. It's minus 5. I also have the minus 5 on that side as well. So this is going to cancel out, okay? So that what I'm left with then is 3x, right? We're just left with 3x on the left side. And that's going to be equal to 20 minus 5 is 15. Now we have a question that's very similar to what we had before. It's just something being multiplied to my x equals a number. So to undo a multiplication, we have to divide by 3, divide by 3. These are going to cancel out. On the left side, all I have then is x. On the right side, I have 15 divided by 3, which is 5. Okay? Now, on to the next question here. So 2x minus 6 is equal to 14. So once again, think about what's going on to your variable first, right? It's being multiplied by the 2 first, and then whatever this product is, this 2 times x, we're going to subtract 6 from it, right? Because of order of operations. So the last thing that happens is that minus 6. So that's the first thing that we should get rid of on my equation, okay? So to get rid of that plus 6, okay, we're going to get rid of that minus 6, I mean, we're going to plus 6. So we're going to add 6 on this side. We also have to add 6 on that side, okay? So these two 6s are going to cancel out. So that all I'm left with on the left side of my equation, okay, remember vertical line here, all I'm left with on this side is the 2x. And on the right side, I have 14 plus 6, that is 20. Now, the opposite of multiplication is division. So I'm going to now divide by 2, so that all I'm left with then on the left side is the x, right? So all I'm left with now is x, and on the right side I have 20 divided by 2, which is 10. Okay? Next over here, we have a very similar question. We have a multiplication, we have an addition, and then equals 3. So let me draw a little line here for you guys. Okay? So multiplication always happens before the addition, right? Well, unless there's brackets, but yeah, there's no brackets here. So there's a multiplication first, and then the addition, right? So what we have to do is undo the addition first. So we have to subtract by 9 on both sides, minus 9, minus 9. These two are going to cancel out, so that all I'm left with on the left side is minus 2x equals, and on the right side I have 3 minus 9, which is negative 6. But we're not done yet, because I want x to be isolated. I want it to be on its own on the side of the equation. So I have to now divide by minus 2 and divide by minus 2 on both sides of the equation, so that these go away, and all I'm left with then is x is equal to positive 3. And I know it's positive because these two have the same sign and they're being divided. Okay? Now, next question. Now this one's a little tricky because we have a division, okay, and an addition. And you might say, oh yeah, because of order of operations, division happens first. But remember, because of this fraction, what's actually being divided is the x plus 3. This sum here is being divided by 5. We have to add these things first, right? In the numerator, this has to occur first before this division by 5, right? So let's think about this. The x is being added to 3, and that sum divides by 5. The last thing that happened was a division by 5. So the first thing we should undo is that division. We're going to now multiply by 5 here, multiply by 5 over here, okay? Let me draw a little line as well. Okay, so this 5 and this 5 are going to cancel out. All I'm left with is my numerator, which is x plus 3, and that's equal to 9 times 5, which is 45. Now we have to undo this plus 3, so the opposite of plus 3 is minus 3. We also have the minus 3 on this side, so that these two go away. I'm left with x is equal to 42. Okay, this question here looks a little bit trickier because it's got a bunch of decimal points, but the concept remains the same, okay? We have a 0.5 times x that's being added to 1.2 is equal to 6.7. So the opposite, okay, let's not talk about opposite yet. Let's think about what's happening first. So we've got this multiplication to the x, and this product is going to be added to 1.2, right? So the last thing that happened was this addition by 1.2. The opposite of adding 1.2 is subtracting 1.2. So we're going to subtract 1.2. We're also going to subtract 1.2, so we undo the addition, right? So these two go away. All I'm left with on the left side of my equation, this vertical line here, is this 0.5x, and that's equal to 5.5. Now, x is being multiplied by 0.5, so the opposite of multiplying is dividing. Oops, wrong color. Pink. There we go. Divide by 0.5. I also have to divide by 0.5 on that side, right? So these two cancel out, and I'm going to be left with x is equal to 11. Okay? So real quick here, this question looks a little bit complicated because of the decimal points, but it's okay. Just treat them as if they were just like integers or whole numbers, okay? The concept is the same. We're just trying to isolate the x. We're just undoing it in reverse order. Okay, next question here. So here we've got x divided by 4 plus 3 is equal to 8. So now it's the x that's being divided by 4, and then whatever this quotient is, it's being added to 3. So the last thing that happened was this addition by 3. That's the first thing we're going to undo. So we're going to minus 3. Oops, I should use pink here. Minus 3 and minus 3. These go away. On the left side of my equal sign, I have x over 4. That remains unchanged. And on the right side, I have 8 minus 3, which is 5. Now I have x divided by 4. The opposite of division is multiplication. I'm going to multiply by 4 on both sides. So these go away. I'm left with x is equal to positive 20. Okay, over here, we've got minus 4x minus 2 is equal to 18. When you have a number and a variable right next to each other, they're being multiplied, right? This is your coefficient, minus 4. So we have to undo the last thing that happened, which was this subtraction, first. So we're going to add by 2, and we're going to add 2. And we're left with minus 4x is equal to 20. And now we want to undo that multiplication by minus 4. So we have to divide by minus 4 and divide by minus 4. These go away. And on the left side of my equation, then all I have is the x. And on the right, I have minus 5. Okay, over here, this one's very similar to one that we've seen before, right? This difference, this subtraction, is occurring first. It's in the numerator. So it's x minus 4. And wherever that difference is, we're going to divide it by 3. So the last thing that happened was a division by 3. That's the first thing that we should undo. So we're going to multiply by 3 here. We should also multiply by 3 on the other side. So we're left with x minus 4 is equal to 36. And now, to get rid of that minus 4, we're going to add 4. We're going to add 4. So these two things, these two 4's are going to go away because minus 4 plus 4 is 0. All I'm left with on the left then is x equals, and on the right side I have 36 plus 4, that is 40. Okay? Over here, x divided by 5 minus 4 is equal to minus 3. So we're dividing x by 5, then we're subtracting whatever that quotient is by 4. That's going to give me minus 3. So the last thing that happened was minus 4, right? The last thing that happened on the left side, I mean. So we're going to add 4, and we also have to add 4 on this side. So these go away, all I'm left with on the left is x over 5. And on the right, I have minus 3 plus 4, which is 1. Now, to undo this division by 5, I have to multiply by 5. I also have to multiply by 5 on the other side, so that these two go away, and I'm just left with x is equal to 1 times 5, which is 5. Over here, I have x divided by 6 plus 7 is equal to minus 2. So x divided by 6, that quotient is going to be added to 7. So the last thing that happened was plus 7. I'm going to now get rid of that by subtracting by 7 on both sides. These go away. I'm just left with, on the left, x over 6. And on the right, I have minus 9. Now I have to undo this division. I'm going to multiply by 6 on both sides so that these cancel out. And I'm left with x is equal to minus 54. All right. Now this question here is very similar to the other one that we saw before, which is we've got a bunch of decimals, right? But once again, it's the same idea. We've got a multiplication, we've got an addition. So this product is going to be added to 1.8 to give you 10.2, right? So the first thing we should undo then is that addition. So we're going to subtract, let me use pink here, subtract 1.8 on both sides so that this goes away. And so that all I'm left with on the left side is my 4.2x, right? And on the right side, all I'm left with then is 8.4. And now, x is being multiplied by this decimal number, but that's okay. It's the same idea. It's being multiplied. To undo it, we have to divide, okay? It's okay, that's a decimal, it's fine. We're just going to divide by 4.2 on both sides. These two things cancel out, so that all I'm left with on the left side of my equation is the x. And on the right side, I'm left with 2. So x is equal to 2. Now going to the next question here. This one seems a little bit more complicated, and we've got a little, like an extra step here, but that's all right. So we've got 2 times this, this sum. I don't know why I lost the word there for a second. So there's 2 different ways you could do this question, okay? And I'll show you both ways. So the first way here, right, we've got this addition that's happening first, right, because of the brackets. And then whatever this sum is, we're going to multiply it by 2. So the first thing we should undo then is that multiplication. We can divide both sides by 2. So that all I'm left with then is x plus 4 is equal to 9. And now we're going to undo this addition, right? So to undo addition, we have to subtract by 4. We also have to subtract by 4 on this side. So that these go away. I'm just left with x is equal to 5, all right? Now, that's the simple way that you could do this question, okay? But another way you could do this question, if you remember from your algebraic equations chapter, right? What we can do, let's rewrite the question. We've got 2 times x plus 4 is equal to 18, okay? If you really wanted to, and you look at this question, you could say, yeah, we can actually distribute this 2, okay, to the sum, right? And all you're going to get is, you're going to get 2x plus 8 is equal to 18, okay? And now, this is very similar to the other questions that we've seen before. We've got a multiplication and an addition. We can undo the addition first. We're going to subtract 8. You're going to get that these cancel out. So 2x is equal to 18 minus 8 is 10. And now we're going to divide by 2 to undo that multiplication. And you're going to end up with the same answer, which is x is equal to 5. Okay? So if you saw this way, you could do that as well. You can get the same exact answer. Okay? It just involves a couple more steps, but it's absolutely fine, completely correct. Okay? Now on to this question here. So x plus 8, that's going to happen first. We're going to divide that sum by minus 7. So the last thing that happened was this division. We're going to undo that first. Okay? So let's multiply by minus 7. We're also going to multiply by minus 7 on this side. So this is going to cancel out. All I'm left with on the left side of my equation is my numerator. I have x plus 8 is equal to minus 20, oh, I wrote 7, 21, okay? And now we want to undo this addition. We're going to subtract 8 and subtract 8 on both sides, right? So that these cancel out, and I'm left with, on the left side, just the x, and on the right side, I have minus 29. Moving right along then, okay, so, oops. We've got x divided by negative 6 minus 4 is equal to 2. So the first thing that happens is division, then we subtract by 4. So that's the first thing we're going to undo is that minus 4. So we have to plus 4, and we also plus 4 on this side. So that these go away, I just have x over minus 6 is equal to 6. And now to undo this division by minus 6, we're going to times by minus 6 on both sides. So that this goes away, and I'm just left with x is equal to negative 36. Okay, now on to the next question here. 4 times x plus 5 is equal to 13. So the first thing that happens is, x is multiplied by 4. This product is going to be added to 5, and that results in 13. So the first thing I should undo then is this plus 5. So we're going to minus 5, we're going to minus 5. These go away. I'm just left with 4x is equal to 8. And now we have to undo this times 4. So we're going to divide by 4 and divide by 4. So these go away, and I just get x is equal to 2. Now, onto this question. So 2x minus 6 is equal to 14. This product is going to subtract by 6, so that's going to be what happens last. So we have to plus 6 and plus 6. Okay, these go away. I'm left with, I feel like I've done this question before, actually. Maybe this is a repeat, but I have 2x is equal to 20. And then I'm going to divide both sides by 2. So that these go away, and I get x is equal to 10. Okay? Yeah, I feel like I've done that one before. Maybe. I don't know. All right. This one here. We've got minus 2x plus 9 is equal to 3. So we're going to multiply this x by the minus 2 first. Then we're going to add it to the 9. That's going to result in the 3. So first was the multiplication, second was the addition. So that addition is the first thing we should undo. So we're going to minus 9. We're also going to minus 9 here. These go away, so that all I'm left with is this minus 2x is equal to minus 6. And now the x is being multiplied by minus 2, so I want to undo that multiplication. I'm going to divide by minus 2. I also have to divide by minus 2 on that side. So the minus 2 and the minus 2 go away. I'm just left with x is equal to 3. All right. Now, this question over here. Okay, so we've got minus 3x plus 9 is equal to 21. So we undo that addition first because that's what's happening last. So we're going to minus 9. We're also going to minus 9 here. So that these go away. I'm just left with, on the left side of my equation, that minus 3x. And on the right side, I'm left with 12. Now, to undo this multiplication by minus 3, I have to divide by minus 3. Why is this not changing color? Minus 3, there we go. And minus 3. So these go away. I just have x is equal to minus 4. On this question here, the 5 is being multiplied to my x. Then that product is subtracting by 12. So the subtraction by 12 is the first thing that I'm going to undo. So I'm going to add 12. I'm going to add 12 so that these go away. On the left side of my equation, I'm just left with 5x is equal to 44. And now I have to undo this multiplication. I'm going to divide by 5. And I'm going to divide by 5 on that side as well, right? So this 5 divided by 5 is going to cancel out, and I'm just left with x is equal to 8.8. Now, on to the next question. we've got x plus 6 divided by negative 8 is equal to 2. So this numerator is being divided by this denominator, that negative 8. So we have to undo that division first, right? Because it's the sum first, and that sum is being divided by negative 8. So I'm going to undo a division by multiplying by minus 8 on both sides, so that the negative 8 and the negative 8 go away. I just get x plus 6 is equal to minus 16. And now I want to undo that addition. I'm going to subtract by 6 and subtract by 6, so that these go away. On the left side of my equal sign, I just have the x, and on the right side I have minus 16 minus 6, that's minus 22. Next over here, okay, x divided by 9 plus 11. So plus 11 is the first thing I'm going to undo. I'm going to minus 11 and minus 11, so that these things go away. Oops, change color. These go away, so that I'm just left with x over 9 is equal to 2. And now x is being divided by 9. I want to undo a division by 9. I'm going to multiply by 9 on both sides, so that these go away, and I get x is equal to 18. Now we've got x divided by 10 plus 14 is equal to 30, right? So this quotient is going to be added to 14. So I have to undo the addition. First, I'm going to subtract by 14, subtract by 14. These cancel out, right? 14 minus 14 is 0. So that on the left side of my equation, all I have is x over 10 is equal to 30 minus 14 is 16. Now, I want to undo this division. I have to multiply by 10 and multiply by 10, so that these two go away. 10 divided by 10 is 1. I'm just left with 1 times x, or just x. And on the right side, I have 160. Over here, I've got 12x plus 48 is equal to minus 36. So I want to undo this addition first, right? Because the x is being added to, is being multiplied to 12, and then that product is being added to 48. So the 48 addition by 48 happens second. So I'm going to minus 48. I'm also going to minus 48, so that these go away. And on the left side of my equation, then, all I'm left with is 12x. And on the right side, I have minus 84. Now this 12 is multiplying my x. I don't want that 12 to be on the same side as my x, because I want to isolate my x. I want x to be on its own on one side of the equation. So I have to undo this multiplication. I have to divide by 12 on both sides. So this goes away. I'm just left with x is equal to minus 7. All right. Now, these last two questions are a little bit more challenging, a little bit more complicated. As you can see, the x, well, the side with the x has a little bit more going on here. So let's kind of just focus on that real quick. And to do that, just to visualize a little bit better, I'm going to kind of bring back that line. And maybe I'll bring the line over here as well, right? So we've got two lines. So let's just focus on the side of the equation with my x. Okay, what's going on here, really? So the x is going to subtract by 13. Whatever that difference is, we're going to divide by minus 2. And then whatever we got from that division, we're going to subtract 5. Okay? X is going to subtract 13, divide whatever that was by minus 2, and whatever that division was, we're going to subtract 5 from it. So the last thing that happened was the minus 5. So that's going to be the first thing that I'm going to undo. Okay? So it might be a little bit more complicated, another operation, but the concept remains the same. We're always going to undo it in reverse order. So we're going to add 5 on this side. We're also going to add 5 on that side, so that these go away. On the left side of my equation, I still have the x minus 13 over minus 2. We don't have to change any of that, okay? We didn't touch it at all, right? So keep it exactly the same. On the right side, I have minus 36. Now, remember we said the x was subtracting by 13 first, and then divided by negative 2. So the next thing that I'm going to undo is that division. So I'm going to multiply by minus 2. I'm also going to multiply by minus 2. So that this and this go away. I just have x minus 13 is equal to positive 72. because there's two negatives being multiplied together. The last step then is to undo this subtraction. It was subtracting by 13. The opposite of minus 13 is plus 13. I have to do that on both sides. These go away, so that my final answer is x is equal to 85. Okay? Now, same concept here. This x is being added to 3. Then it's going to be subtracted by 5, divided by 5. And then whatever that division is, I'm going to add 2 to it. So remember, the order was x plus 3. Whatever that was, divided by 5. Whatever that was added to 2. So the last thing that happened was adding by 2. So that's the first thing I'm going to undo. I'm going to minus 2. I'm going to minus 2. These cancel out. So that all I'm left with on the left is the fraction x plus 3 over 5. And on the right side, I have 9 minus 2, which is 7. Now, I have to remember the order was x plus 3, then divided by 5. So I have to undo the division next, because that was what happened last. So I'm going to multiply by 5, multiply by 5. Okay, these cancel out. On the left side, I just have now x plus 3. And on the right, I have 7 times 5, which is 35. The last step now is to finally fully isolate my x by subtracting by 3 on both sides, so that these go away, and all I'm left with is x is equal to 32. That is my final answer. Okay, and that's going to wrap it up for the 50 solving equations questions. So I hope this helped you practice a little bit, was a little bit enlightening if you were very confused by how to solve equations. We started with one step, moved on to multi-step, and then even more multi-step equations. And yeah, I hope that helps you a bit with algebra. And apart from that, have a great day.